For decades, the internet has functioned primarily as a communication layer, a place to read, watch, and exchange data. Right now, it is undergoing a structural realignment into an invisible execution layer. Traditional software applications are structurally designed to capture human attention. They require manual inputs, pausing critical processes until a person physically clicks a button, reviews a file, or signs a document. In a modern enterprise, that requirement creates a massive bottleneck. Every time a digital system sits idle waiting for human approval, it creates operational latency. That delay represents direct economic leakage, degrading the efficiency of capital. Compare that to the incoming machine economy. Instead of value sitting statically in a database, capital moves and executes dynamically across automated decision flows, entirely outside of biological working hours. This introduces the concept of the zero-human company, a fully autonomous organizational framework where the CEO, the engineers, and the marketing department are run entirely by code. To make this possible, Web3 protocols are shifting away from the speculative trading of digital assets. They are becoming the trustless infrastructure required to support these self-operating workflows. In this post-interface economy, systems relying on manual labor and human trust are obsolete. Market dominance now belongs to architectures that remove human latency entirely, operating continuously at API speed. Artificial intelligence provides the raw cognitive power for this shift, but you cannot simply plug a large language model into a business and expect it to run the operation autonomously out of the box. These models suffer from two critical engineering flaws. First, they have a stateless memory architecture. Second, when left unsupervised, their logic breaks down through the mathematical compounding of probability errors. Even if you stabilize their cognition, these autonomous entities still lack a secure way to hold capital, sign contracts, or interact with traditional banking rails that require a human in the loop. To solve this problem, engineers built the Denarii DFi protocol and its native paperclip orchestrator. This system acts as a centralized control plane, taking isolated chat interfaces and organizing them into structured, persistent corporate hierarchies, allowing discrete AI models to manage enterprise functions. Achieving a deterministic zero-human enterprise requires building a different kind of system from the ground up, starting with how an AI retains its state. The first hurdle is known as the memento man problem. Standard LLM APIs are completely stateless. Between every single prompt, they wake up with total amnesia, possessing immense capabilities but zero situational memory. If you are trying to execute an ongoing strategic plan, this amnesia is catastrophic. An agent cannot manage a corporate workflow if it forgets its exact role and budget the moment a process takes longer than one query. The orchestrator resolves this with a two-part memory loop, the heartbeat check-in system. Before acting, an agent references a structured brief to remember its persona. The second half is the para-memory system, categorizing data into projects, areas, resources, and archives. Instead of forcing the AI to remember its entire history at once, which overloads its active token counts, the agent queries and loads only the specific files it needs for the exact task at hand. By linking that constant heartbeat loop to organized external file storage, the orchestrator artificially generates statefulness. The machine maintains a persistent corporate history without drowning in its own context window. Perfect memory is only step one. When you allow these agents to execute complex, multi-step actions autonomously, you introduce a severe mathematical risk of system collapse. Assume a highly capable AI agent is assigned a task. For any single operational step, it might boast a reliable 95% accuracy rate. If that agent performs a 10-step sequence unverified, the error margin snowballs. Following exponential decay, the success rate drops to 59.8%. This measurability gap maps the cheap cost of automation against the high biological cost of human verification. This creates a dangerous economic incentive. Because raw automation is inexpensive, enterprises are tempted to deploy these unverified systems at scale, actively compounding their operational risk and driving toward a hollow economy. You cannot simply tell the same AI model to double-check its own output. In a linear workflow, a single model will often hallucinate or reinforce its own previous logical mistakes, pulling the entire process further off track. Without a structural intervention to break this chain, A completely unsupervised linear AI workflow is mathematically guaranteed to eventually fail. The required intervention is a rigid, multi-agent hierarchy. Instead of relying on one model to handle an entire sequence, the orchestrator breaks high-level goals into isolated tasks. It distributes those tasks to highly specialized personas, acting as a system of checks and balances. An independent quality assurance agent is introduced. When an engineer writes code, the sequence pauses. The QA node intercepts the data to audit the output. This independent verification resets the probability baseline, dropping the chance of failure to roughly 0.25%. This verified framework is what actually powers enterprise-grade automation, allowing these swarms to safely handle complex tasks like automated smart contract auditing and live treasury monitoring. True system reliability does not come from waiting for a slightly smarter base model. It is achieved through independent agentic verification that mathematically forces the error rate to near zero. An accurate, persistent AI workforce hits a wall if it tries to execute financial operations using legacy banking rails. Traditional finance relies on fixed business hours, multi-day settlement periods, and physical human sign-offs. These parameters are structurally incompatible with machines that think and act in milliseconds. To bypass the traditional financial system, the architecture utilizes 3 ledgers. First, the XRP Ledger provides high-speed value transfer. Second, Algorand ensures pure mathematical transaction finality. Finally, Hedera Hashgraph supplies high-throughput logging, creating a permanent audit trail for every decision. By unifying these 3 ledgers, the architecture creates an environment where machines can hold, move, and transact real-world value with the exact same frictionless speed they use to compute logic. Giving an autonomous swarm full access to file systems and financial execution introduces massive security risks, opening the door to supply chain vulnerabilities and Sybil attacks. To prevent malicious actors from flooding the network, the architecture enforces a strict cryptographic access barrier. Users must cryptographically prove ownership of 2% of the total DeFi supply. If satisfied, the validator node grants access to the dashboard. This access requirement transforms the digital asset. It functions as a prerequisite credential for the validator, ensuring that only highly vested operators have the capacity to deploy these enterprise-grade machine workflows. The blueprint is fully realized: stateful memory frameworks maintaining context, mathematically verified multi-agent hierarchies eliminating error, and multi-chain ledgers settling value instantly. Web3 serves as the invisible settlement rails required for artificial intelligence to act. The network has shifted from an interface for human users to a secure state machine for autonomous agents. Companies that still rely on human management structures, manual data entry, and biological business hours are already operating as legacy systems. They are now competing against networks of executable, non-stop agents. This structural realignment is already rebuilding the global financial architecture from the ground up. Economic value is shifting toward systems that convert human intent directly into flawless, autonomous execution.